So far, we have been using a Spring for our development. Now, we'll introduce a Spring Boot to simplify it. In this module, we'll introduce a Spring Boot and its main features. But first, let's try to understand why we need a Spring Boot. If you think about your applications like web applications or JPA applications, usually we need to define a lot of dependencies in our POM file or build.gradle, and also configure some components inside the application context. Some of these components can be predicted, like in a JPA application, we usually need a data source, a JPA transaction manager, an entity manager factory, so why not let a Spring Boot do it for us? Spring Boot will take care of this low-level configuration, and for that, it will need to make some decisions. And that's why we say that the Spring Boot has its own opinions. We'll see how to override them in a later stage. It's also important to understand that the Spring Boot is not generating any code. It's not a code generator. Everything will happen at runtime. It's not an IDE plugin either. You can use Spring Boot anywhere, maybe on a command line or inside your IDE. It's not an IDE plugin. So the main goal of a Spring Boot is to make your life easier as a developer so you can get started faster and easier. And of course, all these decisions that the Spring Boot will make can be overridden. We'll see different techniques later on that override the defaults from Spring Boot. Spring Boot will also offer all these non-functional requirements that usually we forget about, like metrics or health checks or how to containerize our application. So we'll see all these in some of the next modules. So now we'll focus on two main features in this section, the dependency management and auto configuration. Because traditionally, in a Java application, we need a lot of dependencies. And if you use a framework like a Spring, you'll need a lot of dependencies because we have like different parts of it. And not only from a Spring, but also third-party libraries require a bunch of dependencies. So Spring Boot will take care of all these dependencies for you. So you don't have to spend time including the dependencies in your POM file and also upgrading all these dependencies. We'll be using the Spring Boot parent POM file and the starters to manage all these dependencies. We'll see those in a second. And as mentioned, you can always override whatever Spring Boot pulls into the class path. If you don't like a specific dependency, you can exclude it. If you don't like the version, you can change it. You always have control over your dependencies. This is the Spring Boot parent POM file. As you see here, we define the Spring Boot starter parent, and that's where we define the version of a Spring Boot, 2.7.5. If you go inside this POM file, you'll see a lot of properties that will define or set the versions of all the libraries that are supported, not only from the Spring ecosystem, but also other libraries that are really common in the Java ecosystem, like Hibernate or Tomcat or Jackson. So we see here an example of the Spring Framework. So inside the POM file, you'll see a property called Spring Framework.version, and in this case, it will be set to 5.3.23. So that means that this particular Spring Boot version is tied to this Spring version, and that will happen for a lot of libraries. So Spring Boot will curate a list of libraries that it supports, and they are tested. So all these libraries, or all those versions, are known to be working together. So you don't have to exclude and include other dependencies. We know what the dependency hell is. So we're going to forget about the dependency hell and let the Spring Boot manage those dependencies for us. Now, apart from the parent POM file, we'll be using the starter dependencies. These are nothing more than dependencies that have transient dependencies, so they will pull into the class path some group of dependencies required for a specific part of your application. This is the base Spring Boot starter. This will pull in everything you need to start with the Spring Boot. That includes the Spring Boot jar file, the Spring context, the Spring beans, the Spring core. Those are going to be more than 18 jars. Just one dependency will pull in 18 dependencies. So it simplifies quite a lot the dependency management. And you will find starters for every part of your application. For instance, for testing. If you want to test your application, probably you will need different libraries like JUnit and Mockito and AzurJ and the test context framework. So just by defining the Spring Boot starter test, you're going to pull in all these dependencies into the class path. Really handful. And you'll see the starters for every single part of your application. Usually the starter has a prefix, Spring Boot starter, and you'll have a starter for every single part of your application. JDBC, web, batch, integration, cloud, Redis, Anything you can imagine, there's a starter. You can see them inside the initializer, the Spring initializer, and also inside your IDE when you create a new Spring project. So this is basically how Spring Boot manages dependencies. We'll be using the POM file and the starter dependencies. Now, let's take a look at auto configuration. We have already seen the add configuration annotation. We have seen the add component scan annotation, and now we're going to introduce the add enable auto configuration annotation. This is where all the magic happens. This triggers the auto configuration of your application. So you'll see all these three annotations used in combination, usually together. So instead of defining all these three annotations together, what we usually do is to combine them into one annotation called a Spring Boot application. Notice that Spring Boot configuration is only a type of configuration. We'll see the usage of that when we cover the testing support. But the Spring Boot application will be a configuration class, it will do component scanning, and also it will enable auto configuration. Spring Boot application allows you to define the base package to do component scanning. If you omit that package, what you will do is to scan from where you are. So basically the base package where the Spring Boot application is configured will be where we start component scanning. So this package plus subpackages will be scanned for components. How is auto configuration working? Well, it's going to work based on things that you have in the class path, things that you have in the application context, but here we have a couple of examples. When you include the embedded database dependency in your POM file, of course, let's imagine that we use HSQLDB. HSQLDB will be pulled into the class path, and just because you have this dependency in the class path, Spring will auto-configure a data source for you. It will configure a data source of an embedded database. The same will happen when you define the starter JDBC in the class path or in the POM file. This will pull in everything in the class path, and if you have a data source configured, Spring Boot will auto-configure the JDBC template for you. Of course, you want to use JDBC, you need something to interact with JDBC or use the JDBC API, and that will be the JDBC template. If you don't have a data source, this will throw an exception. Spring Boot will complain and will say, hey, I wanted to configure JDBC template, but you don't have a data source. Please give me a data source or let me auto-configure a data source. So this is how auto configuration works. In the next module, we'll focus on packaging and integration testing.